Okay, so we have two vectors. This is a vector equation, and this is a vector equation. And then we wrote parametric equations for them. This came from across here, for example. And we wrote out three vector equations in green for the top one, and we wrote out three vector equations in blue down here for this bottom vector. And then we set the x equations equal to each other, these guys, and we made this equation. And then we did the same for the y's and then the same for the z's. This one had a very strange third equation, and it's kind of cool. It says that lambda equals t. So once you find t, you found lambda. All right, so I'm going to swap out and put the lambda here, because t is lambda, and I'm going to solve this little equation. I'm going to subtract lambda from both sides, and I get 0 equals -1 plus lambda. Lambda equals 1. And if lambda equals 1, t equals 1. Raise your hand if you had 1. Then that was good. Next step. I got to figure out, I know now that they're going to be at the same time, but are they going to be at the same place at that time? And if so, what is that place? So what do you do with the t equals 1? You put it in. Put it in here. That's the only place where we have a t in our original equations. So we put a 1 in there, and you figure out where it is. Does that for sure guarantee that they're both at the same place at the same time? No. That tells you where the top one will be at time 1. Everybody do that. Figure out where the top one is at time 1. Everybody figure out where the bottom one is at time 1. And if they're at the same place at the same time, then they collide. I'm going to pause for a second. Will you verify when you put in a 1, are they in the exact same place? Okay, so when you put a 1 in, we have 3 plus 1 times 2, and that makes -1. Then we have 0 plus 1 times 1, which is 1. And then we have 0 plus 1 times 1, which is 1. -1, 1 is the spot. Then the other question is, did the other one go through the same spot? Did it? Yes, it did. Because when I put in a 1 down here, I also got -1 for the first one. 0 plus 1 times -1 makes -1. And the other two are also 1, 1. So this one also goes through -1, 1, 1. And then since they both were at the same spot at the same time, lambda equals 1 and t equaled 1. Same spot, same time, they collided. All right. I can't do these forever. I've done for 2 consecutive days. We've practiced problems just like this. And if you don't get this by now, you're going to have to go back and watch the videos and stuff because I can't keep doing these forever. They take a long time. All right. I'm glad you feel like they're easy. They're really not that bad. Now that we've done it, look at how much work it has to be shown, though. Holy cow. These are not super easy to do just because of the algebra. But they're easy to set up, in my opinion. Okay, so what else is there? There's the angle between two vectors. Remember that? All right. The two vectors that we just had a second ago, they can be moved so their tails are touching, and then there'd be an angle between the two of them, right? All right. I'm going to give you 2, and I want you to tell me the angle between them. 1, 2, 1, and 2, 2, 1. Those vectors are different. We're going to call one of them A, vector A, and the other one's vector B. Remember, this is not like an equation for a vector because there's no starting point and no ending. It's just the direction part of the vector. So there's 2 vectors. Remember, you can always move it if you want in your head to start at 0, 0. I want to know what the angle between the two is. There's a formula for that. And if you don't know it by now, you're kind of cooked. So I'm going to give you about 15 seconds to write the formula down. And if you don't already have it written down, we'll check that. Pausing. Okay, here's what it should be. A dot B, magnitude A, magnitude B, cosine of theta. Solve for theta. Dot products. Do you remember the one dot product I told you? If it ever equals blah, what was it? Remember? 90 degrees went with what dot product, though? 0. There's another one like that, but I'm not telling you quite yet. If they are perpendicular, then the dot product is 0. I'll pause for a second while I give that a try. Okay, by now you should have been able to do this. A dot B. That times that makes 2, 4, and 1. What do I do with the 2 and the 4 and the 1? Add them all up. 2 plus 4 is 6 plus 1 is 7, then the dot product is 7. Equals. Magnitude of A, that's just square root of 1 squared plus 2 squared plus 1 squared. And that's going to be 1 plus 4 plus 1, square root of 6. And the other one is 4 and 4 and 1 makes 9. Oh, that one's 3. Exact square root of 9, which is 3. So we could say 3 root 6. See what I did there? I just rearranged them. And then cosine theta. So final answer, if I divide both sides by 3 root 6, I would have the perfect setup for inverse cosine. I do inverse cosine of that. Pausing for a second while I use the calculator. And it comes out to 17.7. Theta equals 17.7 degrees. There, that's the angle between the two vectors. Okay, now these are two vectors that we already know the magnitudes of because we just did it 2 seconds ago, right? And this one had a magnitude of 3, right? Because you did square root of the 4 and the 4 and the 1, square root of 9. How do I change that to a speed? Remember, a magnitude and a speed are the same thing. It's just speed as units. Because if it's a magnitude, that's how far the thing has gone. If it has gone this far, 3 units, 3 feet in this case. If it's gone 3 feet in 1 second, that's the speed, 3 feet per second. See what I mean? So it's the magnitude, it just has to have units. Okay, so how do I give this answer? What's the magnitude of B? The magnitude of B was 3. That's this. What's the speed of the B vector? You'd have to just tell me what units you were using, because that could be 3, what, miles? It could be 3 inches. It could be 3 kilometers. Sure, a lot of things. And then I'd have to know how much time elapsed. It was 1, I know that. But was it 1 second, 1 hour, 1 minute? Yes. Yes. That's tomorrow's review. That's called the unit vector. That's a vector that's 1 long in whatever direction. Okay, so back to this one, speed. It's 3 what? Well, it all depends on what I tell you the units are. Let's say I tell the units are meters and seconds. Then it's 3 meters per second. All you got to do is slap on a unit and you got a speed. Because it's a magnitude, it's a distance already. And I know how distance and time are related because distance equals rate times time. So if I want the speed, that's the rate. If I want the rate, you just take the distance and divide it by time. And the time is always, for a vector, is always 1. From the beginning of it to the end of it is 1 time 1. 1 whatever, I'm going to say seconds. All right. What else do you have to know? Oh, there's so many things. For today, I just want to make you think about one more thing. Let's say we had 2 vectors. At this time, I tell you that the angle between them is 40. Do you get right away you've got a formula and you can stick something in that formula? The angle between them is 40. So here's your 2 vectors. 1, 1, 1. Okay, can you picture that in the room? Over 1, up 1, back towards you 1. So it's like a vector that's like that, kind of. All right. Now, would there be another angle, or sorry, another vector where we have an angle of 40 degrees with that? There'd be a lot of things that have an angle of 40 degrees with that. Exactly. Okay. So could I say that I just have to, you tell me a vector? Well, yeah, except you'd have 3 variables. Do you get how you wouldn't know any of the numbers and you'd have to say this is like A, B, and C was the other vector? Except those aren't good because you already have some things like the vector A, that's in your formula, right? So I'm going to go R, F, and P, my three letters. What I want you to do is just set this up. If I tell you the 1, 1, 1 vector and the RFP vector have an angle of 40, what equation could you write? The angle between those two vectors is 40 degrees. What equation could you write? I know it's this equation, but you got to stick stuff in it. All right, Mr. CW, when I do the dot product of these two, tell me what you get. Okay, help me with it. You're going to do it right now. What do you get when you do that? Yeah, just R. Exactly, and what do you do to them? Yeah, you get R for that, F for that, and P for that, and you're going to add them, and so what do I have on the left side of my equation? Yep. Equals, what's the magnitude of A? That's this one. Square root of. Now you got to add them. You got to want. Okay, so square root of 3. Good. And then how about B? Yep. Awesome. We're almost done. What's the last thing you put in? Except we know theta. What is theta in this problem? 40 degrees. So I put in a 40. There we go. Now, you tell me, if I have 3 variables and only one equation, can I solve it? No. But what if I then told you that F was 2 and R was 1? Could you solve it then? All right, and maybe is a good answer. It is possible that I could give you 2 numbers where you could not make it work. It's possible that this answer could be no solution. You can have vectors where, from what I've told you, you can't make it a 40-degree angle. You know what I mean? All right. That's enough on that. I just wanted to remind you that I could sometimes just tell you an angle, and you'd be able to set up this equation. Okay, now we're going to start the homework together. You stay on your partners because you guys have the same exact homework, and I'd like you to work together till the end of the hour. Here it is. Find day 7. The one that's posted for today. It's called Word Problems. And the only thing that's hard is we are doing the same exact stuff. It's just they've told you a situation with words. Number 1. Have the homework up right now. All right, here we go on number 1. A miniature car moves in a straight line, starting at the point 20. Oh, that's this equation. After t seconds, its position xy is given by the vector equation. So it's basically telling you context around a vector equation. Now, instead of just a generic, like this is an equation, they're telling you that it represents a car, starting at a certain spot. All right. Compared to 0, 0, do you get this car is not going to be at 0, 0 after 2 seconds? It's going to be some other point. Then they're asking you to say how long is the line from 0, 0, which is right here, to wherever it stops. Let's say it stops right there. They're asking you how far is this line. That's a distance between 2 points. You should be able to do that. On the top 20, the distance formula is there. In the first chapter of this whole year, we covered distance formula. So hopefully you know the distance formula. And this isn't that hard. If I tell you t is 1, it's 1 second away. That's pretty easy. This says 2 seconds. 2 seconds. So put a 2 in. All right, so this is really just asking you the same kind of questions as before. If you're picking between two different things, there's two vectors here. Which one do I use? Default to that's the one you probably want. For like speed, for example, when they ask you the speed right here, look at that one when you're doing your speed, because that's the one that's talking about where it moves to. All right. The other thing is you could use this 2 second distance. If you already just found the distance it went in 2 seconds, couldn't you change that into a speed? Distance equals rate times time, and you know the distance it went, and you know the time it went. So you should be able to find its speed from that. All right. Then you're going to do, wait, I skipped. Yep, we're going to here. And this one, oh, it looks so complicated. All it really is saying is it wants it in x and y, which is called Cartesian. Do you get that we've done this little process where we change things like this, which is vector form? We change that into parametric form by making it like this. There, I made it vector form. Is that the one, or sorry, parametric form? Is that the one they want? Nope. They want the other form, which is where you set these equal to each other and get it down to just x's and y's. So you say t is equal to x over 2. And this one is t is equal to y. No, it's not. My bad. Y minus 1. There we go. And then that equals that. Look, Mom, I got an equation that only has x's and y's. So they're saying, I want this equation only with x's and y's, which means they're telling you, take this, make these, and turn it into x's and y's. This isn't the right answer. I'm not doing the problem for you. I'm trying to remind you, you know how to do this. You can take a vector equation and change it into parametrics and then change it into Cartesian. All right, we have a lot of things to review tomorrow, but this is going to be a part of the review right now. This is your homework, and this is helping you review. This little equation right here needs to be made first into parametrics, and then it can be made into a vector form of an equation. Once I got vector forms, it's easy to tell whether they collide or not. All right, and then I only have one other problem other than these 2 pages, and that other problem is this one right here. If you take this as an airplane that goes with this other one as an airplane, and I want you to see if they're at the same place at the same time. In other words, do they collide? It's another one of those. All right, so on this whole page, all I need you to do is, for this problem, is to take this one and this equation that I circled, these two, those 2 equations, and see if they collide, and if so, when. All right. Now, one of the things that's important to me is that you keep doing your homework. So, when I take a look at your homework and you're not doing it, then I'm going to say, deserve to fail. I'm not going to feel that bad for you if you fail a test on Friday. I'm more likely to give somebody a break who has tried really hard, and that would imply do your homework. I know some of you, it's spring, you're sick of school, and you're feeling like just going and watching Game of Thrones instead of doing your homework. There should be some reward for those of you that keep on doing your homework. We got 7 minutes left. I want you to work for another 5 minutes before you pack up. One exception is the kid who leaves early, of course. I understand. That's all I got for you for today.